Okay, so good morning, ladies and gentlemen. My name is Darijav, Regional Manager of SuperMap International. I'm going to share with you all about OneMap solution that SuperMap offers for different industries during past few years. I hope you can more or less get some good ideas and inspirations on establishing such an overall management system. The requirements for natural resource management change based on the development level of it in one country. So at the very beginning, it aims to realize functions like data acquisition and mapping. Later, it deepens to realize data management. And the next stage is business-oriented process management. And next, it goes to integration, sharing, and the whole business process supervision, combining mobile apps and many other IoT methods, Internet of Things, and even some social medias. Like in China, we use WeChat to combine with this process, with this business. So nowadays, natural resource sector requires more developed, more intelligent and powerful management system. So SuperMap summarized them as follow: full space, full factor data management, comprehensive, conjunctive application of massive spatial data, application of new surveying and mapping results using oblique photogrammetry, point cloud, and etc. So, and the application requirements for natural resources informatizations are expression of all spatial data above and below the ground, and large-scale spatial data processing, multi-source heterogeneous data fusion, 3D spatial query and analysis, and multi-end applications such as on PC, on mobile phone, on cloud, and on web. So first, we need to express all the natural resources from the underground to the air. So it's like with different level, a different layer. So in terms of data expression, or let's say visualization, so they're the same. SuperMap provides rich 2D and 3D data model expression methods and symbols. Here you can see on the screen, we have different expression methods. So the spatial structure is as shown on this slide, and SuperMap provides the ability to express full space objects like geology, drainage system, subway system, pipeline, cable net, and stuff. Later, if you want to look carefully into this picture, you can refer to the PDF version that we share on our website. Okay, so my presentation here has 3 parts: SuperMap 2D and 3D integration, because most of our projects and technologies use this part, and SuperMap OneMap introduction, SuperMap OneMap solutions. So let's take the 2D and 3D integration introduction as an entry point to OneMap solution, as well as its examples. So in various geological situations, problems related to karst caves are particularly severe. In actual construction, it's very important to know the distribution range of karst caves, the real-time position of the shield machine used for excavating tunnels during construction, and the distribution of karst caves near the location. With SuperMap, user can view geological data semi-permeably or solidly. So check the geological section of the excavation surface, measure the distance between the current position of the shield machine and the nearest 3 karst caves, etc. So you can see this geological body is in semi-permeably. Okay, so with the support of OpenGI, UGC core, and GPU, SuperMap integrated 2D and 3D technology in 4 aspects: product, data, symbol, and analysis. So all of our products are 2D and 3D integrated. 2D and 3D modules can be run and used in one program at the same time. The 3D module of SuperMap is not a separate product, but an integral part of each product. So it's built in. In addition, we can also display data such as 2D points, polylines, lines, and polygons in 3D. For example, on the left side, it's a 2D plan of a community. Through simple operations like setting the height of the building and adding texture on the surface, building surface, you can get a 3D real estate. So surveying and mapping departments generally have architectural plans similar to this, so that they can quickly display large-scale 3D city panoramas. Yeah, based on 2D data. What else? We support 2D and 3D linkage and mutual query between 2D and 3D and attribute table 3D. So you can see the three parts, they can be shown on the screen at the same time. And you can see the result very clearly with attributes and with picture, 2D picture, 3D picture. This is underground pipeline display map by setting the point to the pipe point symbol and the line to the pipeline symbol. An underground pipeline scene was quickly constructed. So this is setting the point as pipe point. And this line, just setting this line as pipeline. So on the left is a map of a road to be broadened, and we need to determine which buildings to demolish. So we do buffer analysis and then use the results to make a spatial query to get the buildings should be removed. You can see the 2D result and 3D result on the same screen. They are all be highlighted. Another example, this base map is OSGB file obtained by drone. So you can put a road on it using SuperMap. So it means you don't have to go to a software that deals with particularly oblique photogrammetry data. Just finish it on JS software. So the terrain itself has fluctuations, ups and downs, I mean. So its calculation results are more intuitively displayed in 3D. So this is the slope and aspect analysis. You can intuitively view the result combined with professional agricultural factors. We could evaluate which types of crops are suitable for this land, for which part. And this is the fill and cut analysis. This is the view shed analysis to judge where the base station selection is reasonable, whether this base station selection is reasonable, and what areas are not covered. So in the first part, we learned that SuperMap has excellent performance in showing all spatial data. Now let's come to the second part, SuperMap OneMap introduction. So we know remote sensing, GNSS, GIS, they three are the powerful tools for spatial research. They are tightly connected to each other and enhance each other's capacity. Let's say the spatial science as a human, then the working mechanism of RS, GNSS, and GIS is like two eyes and one brain. Remote sensing and GNSS as two eyes to capture, get the data, and GIS works as the brain to command, to control, to manage all the behaviors related to geospatial data. So that's why GIS solutions are so important for a government's overall management. In this case, SuperMap has got an idea, we call it OneMap. All the information and all the indicators of one management system can be stored, shown, and supervised on OneMap system. So the conclusion of OneMap is one set of data, one back page, one check for multiple uses. Generally speaking, OneMap can break through the limitation of the picture frame horizontally and integrate thematic data space, thematic data space vertically. It achieves spatial integration of data through horizontal stitching and vertical overlay, which is the development of file management to database management. So the visualization is the first step to display the multi-source data. The second step, setting the data standard for information integration, sharing, and collaboration mode. At last, we will share the same system and database. OneMap realizes the integration of territorial information on the basis of spatial visualization, horizontal stitching, and vertical overlay, and further realizes information sharing and business collaboration. So OneMap solution solves these 5 problems: disunity in data, isolation, separation of spatial data and industrial data, no big data application, more profession, less supervision. So let me explain a little bit about it. So disunity in data, the data is scattered and the structure is not uniform. So the second one, isolation of different departments. For example, China has built a lot of separated business systems, but these systems cannot connect it with one another. So it costs a lot of money and labor, human labor, to maintain the whole office work. So number 3, separation of spatial data and industrial data. The professional industrial data can't be connected with spatial data. So number 4, no big data application. It can't achieve the application based on this kind of isolated data structure. Number 5, the main functionalities are in the professional industrial factors and few capacity in supervision. So with SuperMap OneMap solution, all the problems will be solved. So OneMap really achieves the full life cycle dynamic management throughout the whole process of planning, design, construction, operation, and maintenance. Based on the core idea of OneMap, we've developed and built a lot of systems, including land use, smart city, meteorology, statistics, ecology, agriculture, forest, real estate, mining, emergency response, disaster management system, etc. So I've listed some of the international applications to show. Yeah, you can check the name later. And here shows all the Chinese national projects developed based on SuperMap. If you want to look through them, please wait for us to share the presentation after this webinar on our official website and social media accounts. So these are all national projects using SuperMap. So let's take some of the industries as example to see how to establish this OneMap system. Actually, whatever kind of management system is, land use, water resource, traffic, and everything, it is all about organizing and managing data, right? So the process is quite similar. I will explain the land use system in detail because of the time limit. SuperMap has made around 70% of provincial land use and cadastral systems in China, and we have been working in cadastral industry since 1997 and made over 100 successful land information systems till now, from national level to province level, county to city level. I believe it can be the proof for guaranteeing the quality of SuperMap's product and services. Generally speaking, the process is as follows. First, we need to collect data using GPS, remote sensing, and land survey. And then we process, store, and manage the land data in established OneMap database, which provides the possibility of the information sharing among different land units. At last, the practical applications can be achieved like e-governance, land planning, land use approval management, land use management, land assessment, and others. So 3 steps. For data collection and processing stage, in recent years, SuperMap has found an efficient way out on oblique photography image by using AI, artificial intelligence technology to make binary classification and even multi-class classification. Based on satellite image, building detection can be fast and precisely made. So this is road extraction on satellite image. This is also the binary classification. And this is the extraction of the bottom surface of the oblique photography image obtained by drone. This is also binary classification. And actually this quality, this image quality is quite high because it's obtained by drone. Yeah, but the satellite image is not so guaranteed, right? Because their resolution has difference. So here it's not binary classification, it's multi-class classification. On the picture of right side, we can see the land is classified as construction land, water, farmland, woodland, and others. Six parts. And object classification for classifying buildings, woods, roads, and lawn. The previous one, it is classifying the land, but this one, it is classifying the objects. So many people may wonder about the detection result accuracy. Here the result IOU is 0.5163. When IOU value is greater than 0.5, it means the result is good. So with more training and higher resolution image, the result could be better because AI is based on machine learning, and the principle of machine learning is deep learning. So we need to train it again and again. So, and the thing is, when a new technology arises, it means it can bring convenience and efficiency in our work, and further save the cost of money and labor. That's why government also pay great attention to it. So after data collection, it comes to the stage of database construction. It follows these steps. I will not read it because it may spend a lot of time. This is the process of constructing database. So the database is supposed to support the transfer in and out of commonly used GIS formats such as CAD, CAD, shapefile, VCT, documents, and others, and using database construction tools to support data input and output, data registration, projection, transformation, format checking, data editing, etc., and should have specialized cadastral subsystems like approval database, land registration database, and household database. So as I said before, the core OneMap database should unify the standard of spatial location, classification, encoding, and data format, etc. The base layer is the basis of all data, and all types of data use the base layer as a unified spatial reference. The upper layer, professional layer, reflects to the state of land and the management, and is the information of the management process and results on the professional level. So database has the functions as below: data standardization checking, database construction, data editing, rights management, land rights management, metadata management, and many others. So this is a data quality check. So data quality check should include topology check, support custom topology rules, support graphical and attributes consistency check. Data editing includes spatial data editing, attribute editing, and stuff. So data change. The system provides a variety of data transfer and editing methods to modify the parcel graphics, such as importing boundary point coordinate files, importing CAD surveying and mapping format data, drawing, segmentation, merging, and mixed segmentation, accurate entry according to boundary points through analytical methods obtained to obtain the boundary coordinates. So enter the field survey data and other attribute information so that the data can be changed. And data sharing module provides a wide range of web services or OGC standard services based on OneMap core database in data center, so that various business departments, other business units, and subordinate business units can use the sharing services together. And after the data is processed into the database, it is necessary to provide the original data, thematic maps, statistical reports, etc. to the Bureau, so they can make decision. The main problem solved by data exchange is the data exchange format and data exchange management. And finally, a set of data exchange standards and data exchange management system is submitted. It mainly provides non-spatial data exchange, spatial data exchange management, data extraction, conversion, etc. Land rights management here is. So it concludes these parts. This is all about land rights archivement. So the land registration database and construction database can be updated in real time. So it means you go to register and the data is uploaded to the database. So after the database is constructed, let's see the process of land registration. In land registration, all related information like parcel number, location, boundary, land type, land price, updated time, nature of ownership, and others will be obtained. In processing stage, you can carry out common business processes such as monitoring business processing, querying project information, editing graphics, printing maps, and exporting card forms. It has realized the process management of project acceptance, cadastral investigation, review and approval, registration and certification. Okay, these are the data sources, mainly has land data and house property data, two directions. Okay, so with a unified database, the system can horizontally connect departments of planning, farming protection, land use, cadastral, and supervision, and vertically get through the land administrative department at county, municipal, provincial, and administrative levels to achieve approval management interaction. Here shows the portal of Ministry of Land and Resource of China. It offers both government and the public the land information through internet, touch screen, big screen, SMS services, social media, etc. It also offers user-friendly customization according to different administrative and organization rule. So that's so-called e-governance. This is displaying registration system of real estate big screen of Jiangxi province, which is located in southeast of China. Besides the portal interface, SuperMap iPortal also provides dashboard to better view the information on maps and graphs. On this big screen, user can monitor the registration situation and daily record of real estate. So the total number of registration, incremental data access, real estate units number, and etc. are shown. As I said before, which analysis indicators and factors showed and displayed, developed on the dashboard are decided by the project or user's demands. So we can customize the development and design on the big screen. Here I listed the selected international land management systems, such as the applications in Botswana, Cuba, Laos, Egypt, Japan, and so on. Okay, now let's come to the next part, water system. On the last topic, I've explained the process of building cadastral systems and the functions that these existing systems have in detail. So GIS works as a tool to visualize all kinds of geodata and further realizes many kinds of analysis to serve for different departments and sectors. So likewise, water system has the similar workflow. The main difference is in data collection methods, which have impact on data type. What else? The factors and content that's shown on portal or dashboard, because we know different industries have different professional industrial data and research content. For example, traffic system needs CCTV, camera video, meteorology system needs satellite image. They're all different. So currently the situation is water data like water resource data, water environment data, water ecology data have their own database. They're not well unified and cannot be shared. There is no good data standard system. The business application system is built separately and lacks unified planning. So these problems lead to the demand of developing various data management portals. So the operations and maintenance costs are very high. According to above mentioned problems, we set the construction goal as 4 points: automatic control, collaborative management, scientific design, and initiative service. The construction workflow is similar to land use system. First is database construction and the platform construction. At last, management and analysis achieved. The interface of overall water management portal contains the water business subsystems of water resources, water supply and drainage, flood control office, and others that you want to add. We need these items to accomplish a water system. Basically, the usage of GIS in water industry contains two contents. One is city water resource management. So the sewage management is involved, like underground pipeline visualization and working status monitoring of pipelines using sensors and cameras. The other is natural water resources management. So the precipitation is an important factor. Also, the dam deformation monitoring should be connected and managed. And generally speaking, urban sewage management system portal should contain these parts. Let's see more functions of this system. It provides pump operations monitoring with 3D scene. Devices like flow meter, sensor, CCTV can help with monitoring and command. And it also provides data analysis like water quality analysis for upstream or downstream and fault analysis of pumping station. Also provides drainage enterprise management. Here it can show the basic information, drainage types, abnormal drainage alarm, and excess drainage unit tracking. I'm sorry that I have to choose this project showing all Chinese words because this system is relatively more complete. Okay, so next, typically related thematic maps have to be included, right? So the attributes of ownerships, materials, water quality, construction time are clearly showed to the governance sectors. In addition of these, like pipeline maintenance can be easily achieved here as well. With the attributes information of pipelines, system can automatically generate the maintenance plan and alert monthly, quarterly, or yearly. Of course, manual maintenance is also should be reported. For task management and data update, you may download SuperMap iTablet from iPhone's App Store or Google. It's a mobile application developed by SuperMap. Using SuperMap iTablet, you can collect data on site and then do the data editing and mapping on your phone. Afterwards, upload the processed data to SuperMap iServer with or without internet connection. So let's see some real cases. This is the water platform of Xi'an City in China. It consists of these parts: portal, precipitation analysis, 3D panorama, video surveillance, and water survey. And it integrated water resources, drought information, flood control system, sewage monitoring, and others. The last topic is agriculture. So in this part, I'll simply introduce the technology that SuperMap applies in agriculture, as well as SuperMap's data processing capacity in this domain, but not the whole process of building this system. So this is not a complete project. We just put some farm satellite picture here to show the dashboard. On the blank part of the dashboard on the left and on the right, we can put agricultural indicators and graphs like temperature, humidity, and nutritional contents of products even. So as a GIS software company, SuperMap, as a GIS tool, GIS is not for processing data, it's only for managing and visualizing data rates. But we can achieve somehow a little bit about this. So we can, this slope and aspect analysis realizes the classification of agricultural resources. And skyline analysis assesses the degree of destruction of natural resources. This is the process of training models, region A and C as training data and B and D as testing data. So we train the model, computer learn it. So we've got the result here. The accuracy rate comes out as 97 and 296%. Even in remote sensing software, this result is good enough. In the testing area, or the whole extent from, this draw data are mainly remote sensing image supplemented by DEM data. So you can see these trees, they are boxed. They're covered by some small boxes. So it calculates the number of trees by this box number. So here comes out the result. Correct box, its rate, and detected tree, its rates. They're both above 95%. So this is also good result. So this is Korean Forest Pest Management System, the administrative map, topographic map, satellite image, terrain, and many other maps and analyses are included in the system. This is another agricultural case in China. It's mainly about planting, field assessment, and soil quality monitoring, professional indicators that nutritional ingredients, humidity, and temperature are connected to the system for fine agricultural management. But the facility have to be very ahead of time. Okay, so let's get review of the whole presentation. So my presentation is mainly about the OneMap solution. So this OneMap solution has 3 steps: database construction and the platform construction, and at last the management, e-governance, and this kind of management platform. So we can connect these systems with our mobile phone and some social media softwares to better manage the data and better do the business. I mean, some water business, land business in government level. Okay, My presentation is done. Again, thanks for your time and attention. Here on the screen is the contact of mine. Please feel free to reach out to me or my colleagues if you need. Thank you.